Good day, everyone. We are Group 1, and today we will be presenting our topic about Hamilton's method. So please sit back and listen as we walk you through this topic.
Good day, everyone. Today we will be discussing Hamilton's method, also known as the method of largest remainders. This method is used in mathematics to fairly distribute or apportion a fixed number of seats or resources among different groups based on their population. It became one of the earliest methods used to determine how seats in the United States House of Representatives could be fairly divided among states according to their population. In this presentation, we will explain what Hamilton's method is, the steps involved in applying the method, and how it works through an example. By the end of this report, you will understand how mathematics can be used to ensure fairness when distributing limited resources among groups.
Good day, everyone. I am Merfait Elaine Garcia Mendoza, and today I will be having a simple and brief explanation of the description about Hamilton's method. Do excuse my voice because I have recently lost it due to the recent events. So Hamilton's method was proposed by Alexander Hamilton. It was the first apportionment method approved by the United States Congress, but it was later vetoed by President George Washington. Despite this, the method was still used at different times between 1852 and 1901. And based on my other searches on the internet, it was actually 1911. But 1901 is actually based reference on the book, the mathematics book that we had. So let's keep it there. This method is used to allocate legislative seats among states based on their population. First, the population of each state is divided by a standard divisor to get the quota. Each state is then given its lower quota, which is the whole number part. The remaining seats are distributed to the states with the largest fractional remainders. Because of this process, Hamilton's method sometimes tend to favor larger states.
So now let's move on to the terminologies. So Alexander Hamilton developed terms and formulas used to calculate. So these terms are standard divisor or SD, standard quota or SQ, lower quota or LQ. So let's tackle first what is SD or standard divisor. So standard divisor, this is the number of people each seat represents the House of Representatives. So SD or standard divisor is calculated by dividing the total population of all states by the number of voting seats available. So we have here SD is equals to total population divided by the number of seats. Next is we have standard quota or SQ. So standard quota, this is the number of voting seats each state should receive. So SQ is calculated by dividing the total population of each state by the standard divisor. So the value of this is usually a decimal, but in rare cases, it may be a whole number. So we have here SQ is equals to total population in a particular group divided by the standard divisor. Lastly, we have lower quota or LQ. This is the whole number of the standard quota. So LQ, this is the minimum number of seats of a specific state should receive. This is found by looking at the whole number of the standard quota without the decimal values on it. So for example, if your standard quota of a state is 8.27, then your lower quota is 8. And the next one is the steps and procedures that will be discussed by the next reporter.
So hi, I am Drew Ashley Buhian, and the procedure in solving apportionment using Hamilton's method, we have 5 steps. Step 1, solve for the standard divisor. To do this, divide the total population by the total number of seats that need to be distributed. This tells us how many people should be represented by one seat. Step 2. Determine the standard quota for each group by dividing its population by the standard divisor. This shows how many seats each group should get. Step 3. Round each group's standard quota down to the nearest whole number. So we round down because seats cannot be divided into decimals or fractions, and this is called a lower quota. Step 4. Sum or add the lower quota to find how many leftover seats exist. This helps us see how many seats are already given and how many seats are still left to distribute. Step 5. Allocate the leftover seats one at a time to the group with the largest decimal remainders or largest fractional parts in their standard quotas until no leftovers remain. In simple terms, Hamilton's method first distributes seats fairly based on population, rounds down the values, and then gives the remaining seats to the groups with the biggest decimal remainders.
Now, I'll present sample problem number 1 using Hamilton's method. Suppose a university plans to distribute 20 scholarship grants among 5 departments based on the number of students enrolled in each department. The total number of students in the university is 5,000. The number of students in each department is as follows. Nursing has 1,600 students, Education has 1,200, Engineering has 1,000, Business has 800, and IT has 400 students. Using Hamilton's method, we will determine how many scholarships should we assign to each department. The first step is to find the standard divisor. We divide the total number of students, which is 500, by the total number of scholarships, which is 20. 5,000 divided by 20 is equal to 250. Therefore, the standard divisor is 250. Next, we determine the standard quota for each department by dividing the number of students by the standard divisor of 250. For nursing, 1,600 divided by 250 equals 6.4. For education, 1,200 divided by 250 equals 4.8. For engineering, 1,000 divided by 250 equals 4.0. For business, 800 divided by 250 equals 3.2. For IT, 400 divided by 250 equals 1.6. These values represent the standard quotas for each department. In this step, we round down each standard quota to the nearest whole number to get the lower quota. For nursing, 6.4 becomes 6. For education, 4.8 becomes 4. For engineering, 4.0 becomes 4. For business, 3.2 becomes 3. And for information technology, 1.6 becomes 1. Next, we add all the lower quotas. 6 plus 4 plus 4 plus 3 plus 1 is equals to 18. Since the university needs to distribute 20 scholarships, there are 2 scholarships remaining. To assign the remaining scholarships, we'll look at the decimal remainders. The remainders are: for nursing, 0.4, education, 0.8, engineering, 0.0, business, 0.2, IT, 0.6. The 2 largest remainders are 0.8 and 0.6, so those departments receive the additional scholarships. Therefore, this is the final distribution of scholarships. Nursing has 6 scholarships, education 5 scholarships, engineering 4 scholarships, business 3 scholarships, IT 2 scholarships. This is the final apportionment for sample problem number 1 using Hamilton's method.
A university is forming a student leadership council that will represent different departments in the school. The councils will have 12 total seats, and these seats must be distributed among the departments based on their number of enrolled students. The university administration is decided to use Hamilton's method to fairly allocate the seats. The student population is shown below. So in each department, nursing has 560 students. In the Department of Pharmacy, it has 340 students. In MedTech has 220 students, and in Physical Therapy it has 180 students. A total of 1,300 students. The second step is to find the standard divisor. The standard divisor is found by dividing the total population by the total number of seats available. In this case, we divide 1,300 by 12. This gives us approximately 108.33. The number represents how many students correspond to one council seat. We find the standard quota for each department. To do this, we divide the population of each department by the standard divisor. For nursing, we divide 560 by 108.33, which gives us approximately 5.17. For pharmacy, we divide 340 divided by 108.33, which is approximately 3.14. For MedTech, 220 divided by 100.33 is 2.03. For Physical Therapy, 180 divided by 10.33 is 1.6. The next step is to assign the lower quotas. This means we only take the whole number part of each quota and remove the decimal. So nursing gets 5 seats, pharmacy gets 3 seats, MedTech gets 2 seats, and Physical Therapy gets 1 seat. If we add these together, we get 11 seats in total. However, the council should have 12 seats, which means there is 1 seat left to distribute. Hamilton's method is to give the remaining seat to the department, which is the largest decimal remainder. Looking at the decimals, nursing has 0.17, pharmacy has 0.14, medtech has 0.03, and physical therapy has 0.66. Since 0.66 is the largest remainder, the remaining seat is given to the physical therapy department. Therefore, the final seat distribution is nursing with 5 seats, pharmacy with 3 seats, medtech with 2 seats, and physical therapy with 2 seats, making a total of 12 seats. In conclusion, Hamilton's method helps distribute seats proportionally by first assigning the lower quotas and then distributing the remainder seats based on the largest remainder.
Sample problem number 3. A healthcare facility needs to distribute 20 new nursing tablets across 4 different specialized wards based on the number of staff in each department. The facility decides to use Hamilton's method for equal distribution. Here in our table shows the ward and the number of staffs in each ward. For pediatrics, the number of staff is 155. For emergency, we have 240 staff. For ICU, we have 102. And lastly, for general ward, we have 83 staffs. Total into 580 number of staffs. Step 1. Standard divisor. Formula. Standard divisor is equals to total population divided by total items. So from our problems earlier, we have 580 divided by 20, and that is 29. So our standard divisor is 29. For pediatrics ward, the number of staff is 155 divided by 29, and we get a standard quota of 5.34. For the emergency, the number of staff is 240 divided by 29, and we get 8.27 standard quota. For the ICU, number of staff is 102 divided by 29, and we get 3.51. And lastly, the general ward. Number of staff is 83 divided by 29, and we get a standard quota of 2.86. In step 3, we take our standard quotas and round them to the nearest whole number to find the lower quota for each ward. This gives us a baseline distribution wherein pediatrics gets 5, emergency gets 8, and ICU gets 3, and lastly general ward gets 2. Moving on to the calculation. In step 4, we found that the sum of our lower quotas is 18, leaving us with 2 remaining tablets to distribute. In step 5, we look at the largest remainders from our initial calculations. Since 0.86 and 0.51 are the 2 highest values, then the extra tablets are assigned to the general ward and the ICU. Finally, after calculating the standard quotas and reminders, our final distribution is as follows. For pediatrics, they receive 5 tablets, emergency 8, ICU receives 4, general ward receives 3, and this accounts for all 20 tablets allocated according to staff density.
For the conclusion, our topic shows the importance of following clear steps and using logical thinking when solving mathematical problems. Mathematics is not only about getting the correct answer, but also about understanding the process used to arrive at the answer. By identifying the given information, applying the correct procedures, and carefully solving each step, we can avoid mistakes and develop stronger problem-solving skills. Through the samples, problems, and solution we presented, we can see how the concepts are applied in real situation. Understanding these processes helps students become more confident in solving similar problems in the future. Overall, this topic reminds us that practice, patience, and understanding the essential in learning mathematics effectively.